Okay. So now what experiment we are going to do is the circuit diagram is this. You have one LCD. The LCD data pins are connected with the port C. What is it? RC0 to RC7. And the configuration pins. What are the configuration pins for LCD? RS11. So all these three pins are connected with the RB0, RB1, RB2. Okay. So done. So LCD, I hope like everybody clear. No doubt in that. Now coming to the sensor part. So this is your LM35. This LM35, as I already mentioned, one pin is power supply. This is you are giving, and other end is like you are giving ground. So supply you are giving, and then the output pin. This output pin you are taking and you are connecting to the output of this sensor is what type of output? Again, whether it is analog or digital. Analog output. Okay. So already we have seen some input-output ports. Port A, port B, C, D, E. Okay. So these 5 ports are analog port or digital port. Are we giving analog input or analog output we are taking, or digital input, digital output? These all 5 ports are digital input output channels or input output port. Okay. So you are giving input also digital input. Either you are giving 0 volt or you are giving 5 volt. Correct, right? So when it is producing output also from this channel you are getting 0 volt or 5 volt. Not in between voltages. Clear, right, everybody? So all these 5 ports are digital port. So you can give only digital input or digital output you can expect. Now this LM35 is producing analog output. You need to give this analog to some analog channel, not for the digital channel. Getting right? So you cannot give this LM35 output to any of this channel. Is everybody clear with it? Okay. So you need a analog channel. Okay. So in the pin diagram, when we discussed, I think we have discussed RA0/AN0. If you check your pin diagram, RA1/AN1, RA2/AN2, like that we discussed. Okay. So now what we are going to do is we are going to use these analog channels. How many analog channels are there? 3, 5, 7, 8. Okay, so 8 analog channels are there. AN0 to AN0, AN1, AN2, like that up to AN7. So there are 8 analog channels are there. Okay, here and there. I mean, it's not in order. It is like some gaps are there. Okay. But anyhow, that's fine. That's fine. Okay. So in the left side it is there. So RA0/AN0. Now we are not going to use it as a port A. We are going to use it as a analog port. So this we are calling it as a analog port. In this analog port you have 8 channels. Clear, everybody? So port A we have 6 channels, port B we have 8 channels. No? Similarly, we have only one analog port. In that analog port we have 8 channels. Clear? Now, for this purpose we don't want all 8 channels, because only one analog data you want to give it inside this microcontroller. Please everybody follow this. This is like a kind of big story. Okay. So you need to follow each and every step. If you are like missing one step, now again you will be little confused. If you have any question, you will please stop and you can ask me. So from this LM35, the analog voltages keep coming. That analog voltage you need to give it to analog channel. Now assume that you can give it in this 8 channel, you can give it to any one channel. It is not that like you are going to give for all channel, because only one you have to give. No. So let's give to AN0. you are giving to A and 0. So I am connecting to A and 0. Again, you can give it to any one channel. It is not particularly A and 0, just it's a first channel, so I am giving like A and 0. Clear? Now your job is done. So the circuit connection is only this much. Inside and all you forget. Inside that is like an internal concept. The circuit connection wise, LCD you are connecting, the LM35 you are connecting to A and 0. That's all. That's the circuit connection. Now, sir, what the next thing is like any microcontroller or microprocessor. Already we discussed in the first beginning class itself. We discussed microcontroller or microprocessor is working in it can understand only binary language, correct, right? It can understand only zeros and ones. But now if you are giving 5 volt or if you are giving 0 volt, it will understand 5 volt means it will understand 1, 0 volt means it will understand 0. But you are giving 3.5 volt, 3.75 volt, 4.25 volt, 4.75 volt. Got it, right? Now how you will understand? That is the analog voltage. Got it, right? So analog cannot be processed by the microcontroller. The microcontroller can process only the digital data. That is only it can process the binary data. Getting right, everybody? So what we want to do is this analog data need to be converted to digital. So that we need one ADC. Again, ADC, it is already available in your microcontroller. You just need to enable it. You just need to configure it. Got it, right? Like yesterday we discussed timer. Timer is there, you are just configuring it and you are using the timer. Interrupt is there, you are just configuring it, you are using the interrupt. Similarly, within your microcontroller, already ADC is there. Okay, you just need to tell that ADC bus in A and 0, I am giving the analog voltage. You take that analog voltage and you convert it to digital data. It means you need to do some configuration. That's what we are doing here. Got it, right? I will explain. No worries. Just as of now, you understand that we are configuring the ADC in these two lines. Clear, everybody? So LM35 is producing analog voltage. That analog voltage we are giving to analog channel. But your microcontroller works in binary, so he needs the data in a digital form. He needs the data in the binary form. So analog he cannot process. So that what we are doing is we are configuring the ADC. Inside your microcontroller, ADC is already available. You are just enabling the ADC. So you are asking the ADC to take analog voltage from A and 0. And what ADC will do, right? It will take the voltage and it will convert that voltage. Let's take it, the voltage is coming 3.75. That 3.75, you will convert it as a binary number. Got it, right? For 3.75, what is the equivalent binary number? So you will convert that binary number and you will put it into the register output. Since this microcontroller is how many bit microcontroller? 10 bit. 8 bit. Okay. So this microcontroller is a 8-bit microcontroller. So it will have a 8-bit register only. Correct, no? But this ADC is a 10-bit ADC. It means it is nothing but a 10-bit ADC means it can produce the output as a 10-bit number. That's the meaning of 10-bit ADC. If it is producing the output as a 12-bit number means it is a 12-bit ADC. Got it, right? If it is producing output as a 8-bit means it is a 8-bit ADC. So whatever the voltage is coming, that voltage is translating to 10-bit binary number. Clear? That is the job of the ADC. So ADC is converting the analog voltage into digital. Digital is nothing but your binary number. It is converting it as a 10-bit binary number. Since it is a 8-bit register, so you need a 2 register. Correct, right? One register you can store only 8-bit. Remaining one register you will store the 2-bit. So that it will in the 2 register you can take the value. That 10-bit value you are taking and then you are trying to display it on the screen. See what we want to do. There is some temperature. Listen here. It's a very important concept. There is some temperature. The temperature, let's assume it is a 50 degrees Celsius. Okay. That 50 degrees Celsius is converted as some voltage. That voltage is converted as a 10-bit number. Got it, right? The 10-bit number, again you want to convert it to the original voltage, original temperature, and you want to display it here, temperature is equal to 50 degrees Celsius or temperature is equal to 70 degrees Celsius. Because thermometer, what it is doing, whatever whatever temperature is there in this particular place, the temperature is displaying it. He is not actually directly displaying it. So sensor is detecting the temperature is converted as a voltage, that voltage is converted as a 10-bit number, the 10-bit number is again reversed back. Again, just a simple maths, don't worry, I will help you on that. So the 10-bit number is again reversed back to the actual original temperature, then the temperature 40 degrees Celsius or 70 degrees Celsius, like that it will be displayed. So the final output is temperature is equal to 46.72 centigrade, like that it will be displayed. Clear? So here 46.72 degrees Celsius is the centigrade is the, that is converted as a some voltage. That voltage is converted as a 10-bit number. Then here we are going to do some maths to convert it. The 10-bit number we are going to convert it as a actual original temperature. Then we are going to put it into this LCD and we are going to display it on the LCD. That's all. That's what the even our thermometer is doing. Clear, everybody? Any confusion in the overall the experiment? Fine. Okay, this I will explain in the program. Now, you need some time. No, not break. To recall it. Okay, fine. So now this in programmatically, for this what is the program that we will see. Okay. As usual, I am just declaring one global variable ADC. Actually I am supposed to declare here, but I forgot, so that I declared above. Okay, no, there is no special reason to keep it above. Okay. So this you are supposed to declare here. Okay. As included stereo, this oscillator frequency, this all I think you are clear. Okay. And this function is interrupt ISR. Okay. So again, now you must be thinking, sir, where the ISR is coming into this? What is the role of the interrupt here? Correct, right? Very good. See, the voltage will be taken by ADC. ADC will do converting that voltage into 10-bit number. So once he converted to 10-bit number, no, immediately he will raise interrupt. Boss, I have done my job. Got it, right? So that once he raised an interrupt, you can go and take the 10-bit value and you can use it for your program. Again, you have to start the ADC. See, ADC every time you need to start. That is what you are doing here. Start the ADC. I will explain. Just as of now you understand. Okay, this line we are doing that line we are doing that. Okay. Anyway, each line I will explain. So every time you are starting, once started means ADC will take this voltage. He will do conversion. Once conversion completed, he will put the data into that 2 register and he will raise an interrupt. So interrupt is coming means now you are going to interrupt service routine, taking that 10-bit value. Okay. And again you are coming back here. Again you are doing some job. Again you are starting this ADC. Every time you need to start. You are starting the ADC. It will convert, and once conversion completed, interrupt will come. You are going to interrupt service routine. You are taking the data, and then again you are coming and you are displaying it. Clear? That's the procedure. Okay. So now Already I told ADC converted result will be there in two registers. Those two registers are ADRESH, ADRESL. These are the two registers. It is 8-bit, it is 8-bit. Got it, right? So that is the reason you see here, we are taking it from this. So the data, let's take the data will be there like this. Here 2 bits, here 8 bits. Got it, right? So here 2 bit, here 8 bit is there. I'm saying like in ADRESH, the first 2 bit and ADRESL 8 bit. So total 10 bit data. Clear everybody? Now assume that interrupt is coming. Now you are coming here. Okay, in interrupt service routine what we are doing, let's understand. So it is coming here, the flag will be 1. It will go in here, just as some delay you are giving. If any like oscillation or any work is there, let it get settled, so that you are giving some delay. And ADRESH, you are doing left shift by 8 times. So why we are doing this is, this actual 10-bit data, now we are planning to put it in a 32-bit variable. ADC is a what variable? Integer variable. How many bit? 32-bit. Got it, right? So in that 32-bit variable, you are trying to put this 10 bits. Got it, right? Because you want to put it in a single place, not in like a two separate register or some other. So what you are doing is ADRESH, you are doing left shift. It means like a ADRESH, like a this 8-bit will be going to one place, and that will be put it into the second byte of your ADC. Getting right? In ADC you have 4 bytes. So ADRESH will be put it into the second byte. ரொம்ப சிம்பிளா சொன்னா ADRESH ல என்ன இருக்கோ அத வந்து உங்க ADC ன்ற integer variable ல second byte மூவ் பண்றீங்க. Just a basic bitwise operator. You have 4 bytes for ADC. Okay, so this ADRESH you are putting here. That is what you are doing in this line. Getting? So in this line, what you are doing, whatever you have in this ADRESH, the 2-bit data you have. That 2-bit data you are putting in this second byte of your ADC. This is first byte, second byte, third byte, fourth byte of your ADC. Clear? Next, what you are doing, that ADC you are adding with the ADRESL. Already ADRESL you have 8-bit. Now that 8-bit will go to the first byte of your ADC. You got it, right? So in this 2 line, what ultimately you are doing, in this ADC, these 2 register you are putting here. Any confusion in these 2 lines? Clear, right, everybody? Okay. So very simple. Whenever interrupt is coming, it means that the 10-bit value is present in these 2 registers, ADRESH, ADRESL. So from this ADRESH, you are taking into the second byte. From ADRESL, you are taking into the first byte. That's all. If it is confusing, later you just like go on the recall once. Okay? And then you are making the flag to 0. And you will come back to your main function. Clear, everybody? Okay? So in interrupt service routine, you are not doing anything. Whenever interrupt is coming, you are going to that interrupt service routine, you are taking that value and putting into a variable. That's all. And the register value variable kulla potukreenga avladha, vera edhum pandradhu. And then you are coming back to your main function. Now once you come back here, since we are using interrupt, correct now? So you need to enable GIE, PIE and ADC interrupt you are using. So AD interrupt enable you are making it to 1. Next, since you are using port D and port C, that you have to configure it for the output ports. So TRIS D, TRIS C, port, everything you are initializing to 00. And then LCD init, LCD command. LCD command 0x80 means first row, first column. Very good. So you're moving to first row, first column. Yeah. And then LCD string temperature. It means like just you are displaying the string temperature on the screen. Till this everybody clear? Any confusion? Okay. Now these two line is related to your ADC configuration. This I will explain. Okay. So how to configure what are the configuration you need to do. Okay, this I will come. Next, coming to while loop. Okay, assume that you configured it. It means you configured to take it from the ADC. You are enabling ADC asking. You are asking the ADC to take the analog data from the AN01. Okay. For that only you are doing this. Next, you are coming to infinite while loop, and here in infinite while loop, AD count 0 equal to AD count 0 or with 04. So it is very simple, nothing but what you are doing, every time you are doing the start of the ADC. See, enabling ADC is different. See, the scooter, you are plugging in the scooter, you are plugging in the key. It means like you enable the scooter, but still you will not start the scooter because you don't want to waste your time, you don't want to waste the fuel. Whenever you want to move the vehicle, you will start the scooter. Correct, no? So one is like you are enabling ADC as well as like you are starting the ADC whenever it is needed. Got it, right? So here you will enable the ADC and here you are starting the ADC. So every time you are coming and starting the ADC. Once you start the ADC, what ADC will do? He will take the voltage from this channel and he will start converting that voltage to 10-bit data. Once it is converted to 10-bit data, he will raise an interrupt. Once interrupt comes, you are going and taking the data into the variable ADC. Now the 10-bit is available in this ADC variable. Got it, right? So now you are coming here, you have the 10-bit data in this ADC. Got it, right? So that ADC you are doing divided by 2.0466. Why we are dividing with the 2.0466? Okay, let's understand that. So why we are dividing with the 2.0466 is, see, there is a two conversion happens. One is this temperature is converted to 0 to 5 volt. Listen carefully, this is very important. So let's take I've shared one document. I hope like everybody able to use your mobile, right?